Using the built-in Python functionality of the AMS modeling suite is easy, effective and fun. We know many of you are already making good use of scripting. For all those and everybody who wants to get started, we have now compiled a scripting cookbook filled with reusable code snippets for recurring molecular modeling tasks. Whether it is looping through a trajectory, counting sp3 carbon atoms or finding the smallest set of rings, the recipes stem from various areas and are continuously updated by us. Let's have a look at some examples contained in the cookbook. Here I have a dicyclopentadiene molecule for which I'm running a DFTP geometry optimization. Once the calculation is finished, I open the command line from the AMS jobs GUI. If you're on a Windows computer like me, type the keyword bash before continuing. To start an interactive IPython session, type AMS IPython and hit enter. For the recipe I want to show, we will need to import the plums in the ADKit library first. Note that in this interactive IPython environment, you can use the commands ls to show the contents of the current directory, cd to change the directory, and most importantly the tab key for command completion. You can load the optimized dicyclopentadiene molecule by passing it to a plums molecule. Here I just passed the location of the DFTP output file directly. It's found in the calculations.results folder and I use the tab keys to locate it. Once I've created a plums molecule, I can convert it to an ADKit molecule. With the preparation all done, I can now start applying the cookbook recipes. Let's first count the number of rings. Type chem.calc and use the tab completion to find the function called calcnumRings. Just pass the ADKit molecule and hit enter. There you go, 3 rings were found just as expected. Let's calculate the fraction of sp3 hybridized carbon atoms next. Just type chem.calc again and tap your way to a function called calc fractions csp3 and pass the ADKit molecule again. Now we see that 60% of the carbon atoms are sp3 hybridized, which in this case can be easily verified to be correct. Of course, all the interactive Python commands can also be written to a script that can then be executed automatically. How that is done alongside more recipes is found in the cookbook. I put a link in the video description. I hope this will prove useful to your research too, and as always, we are happy to answer any questions and comments below this video.